Hello everyone, this is Hating Tian. This video we are learning 3.3 polar coordinates. So we have learned if I want to find a point, the point has the x, y's value. Now, so this one is a rectangular coordinate. Now we're describing the point by using polar coordinate. We're using r, theta. So memorize that r is the distance from origin to the point here. We say this is r. Theta is the angle here, angle theta from initial to the terminal. So it's not equal to x, y. So x is not equal to r, y is not equal to the angle theta. So let's see. If I have 4 points and we need to plot the points on the polar coordinates plane. So first we have the point which is 3,60. 3,60. That means r is 3, theta is 60 degree. We always starting from the theta. So we say angle goes first or theta goes first. Let's find the angle 60 degree. So this is the polar coordinates plane starting from 0 and the counterclockwise rotation. So this in the middle 45 degree. So here is 60 and here is 30 degree and this is 15 degree. You can see from here to here. All right, 60 degree is here. That means I'm rotating this way. And how about the r? R means the distance from origin to the point is 3. So 1, 2, 3. Okay, my point is here. So we have a lot of circles. The circle in the middle, the radius is 1, radius 2, radius 3. So finding the r radius is equal to 3, which is to find the point on the third circle. Okay, what do we need? We only need this point as I plotted here. So the first point represents 3,60 degree. And the second point, we can use different color. For example, if I'm using -5, 120 degree, use this color. First find the angle 120 degree. So 120 degree is here. So it's here. I'm rotating from initial to here is 120 degree. And we are having -5. What is the meaning of radius is -5 or r is -5? That means we're having opposite direction. So first, let's find 5, 120 degree. So 1, 2, 3, 4, 5 is the point here, but the opposite direction. So let's go this way. Okay, here, and then count for 5. 1, 2, 3, 4, 5. Okay, my second point is here. So first find the angle 120 degree. Second, find the +5. Then reverse the direction to opposite. Then we have -5, 120 degree. So we can erase these helping information, including the line. So the second one, we use this color. And third one, let's choose red. We have 4. We have +4, -90 degree. Let's find where is the angle -90 degree. I'm rotating clockwise. Okay, so now the terminal side is the straight line here. And then the radius r is 4. That means I'm going down 1, 2, 3, 4 unit. So my red point is here. I can erase the helping information. So r is positive. I don't have to go backward. Go to the opposite direction. Okay, let's see the last one. Let's pick green. So last one is -4, -120 degree. We're always starting from the angle. So -120 degree. Where is the -120 degree? Here. I'm rotating this way. So the terminal side is here in green, and then the r is -4. So let's find -4. Let's find 4 first. 1, 2, 3, 4 is a point here, and I'm going backwards. So 1, 2, 3, 4. Okay, the green points. The last point is here. Okay, we can erase the helping information. So we found the 4 points on the polar coordinates. All right, let's move on to see next example. Find the 4 points. Very similar. Okay, first point is 5, 30 degree. First find 30. So this is 0, 90 degree, and this is 15 degree. This is 30 degree, 45, and 60, and 75. Okay, so 30 degree is here, terminal side, and 5 is 1, 2, 3, 4, 5. Okay, is a point here. Maybe we can make a big mark here. And erase the helping information. And the second, I'm using different color. Let's use blue. 5, -3, 30 degree. Where is the angle? Angle first. -330 degree. So I'm starting from initial and rotate clockwise. So I stopped here. So this is a terminal side. So for this terminal side, so what is the R? R is 1, 2, 3, 4, 5. Okay, I highlight this point again. Okay, they have the same points. So the first point and second point, they are the same point, but it's a different expression. How about third point? Let's use red. Let's use red, which is -5, 210 degree. So let's find the angle 210 degree. So I'm starting from initial and the positive 210. I'm rotating to 180 and continue to another 30 degree. Oh no, here. Okay, this is a terminal side. What is the R? -5. So positive 5 is 1, 2, 3, 4, 5. So -5. Okay, it's very interesting. I highlight this point again because go opposite and then count 1, 2, 3, 4, 5. Same point. So let's test if the last point is still at the same point. Let's use green. So it's -5, -150 degree. And let's see where is the angle -150 degrees starting from the initial and rotate the clockwise. So from here to here. So initial side is here. Okay, so the R is 50. So, sorry. The R is -5. That means I'm counting positive 5 first and then going backwards. So the green point is also here. So these 4 points, they have different R, different angle, but they represent the same point. Okay, let's erase the helping tools, helping sketches, and we did the conclusion. These 4 points, 4 expressions in the polar coordinate expression, so they represent the same points. Okay, for example, later I gave you this point. Can you use 4 different R and angles value to describe this point? Yes, we can do that. Okay, let's see next example. How to plot the polar coordinates if the given point is 5, 120 degree. So this is R, theta. So first, I shouldn't have these. Okay, first, I should find the angle 120 degree. So where is the angle 120 degrees? Starting here and rotate counterclockwise. Okay, this is my terminal side. Okay, the R is 5. 1, 2, 3, 4, 5. Okay, the point is here. I can erase the helping tools. So ignore the red and the green arrows. So this point is 5, comma 120 degree. If I want to find another 3 points and 2 of them, so totally 4 points, 2 of them they have a positive R, which is 5, and 2 of them have the R, which is negative or negative 5. Okay, let's see. Based on this angle, positive 120. So what is the coordinate? So coterminal angle. So I'm rotating this way. So coterminal angle, that means I plus or minus 360 degree. I have the same terminal side. So the second point, I can use 120 degree minus 360. I'm using the backwards rotation. And then the second point is 5, comma. So do the math. We have negative 240 degree. And how about the third point, which the R is negative? So we can erase all of this, and we can keep the terminal side here. Okay, if the R is negative 5, that means it has the opposite direction as positive 5. Okay, that means if I can find the opposite direction, so this is positive direction, and then what is the opposite direction? Okay, here. So this is the opposite direction. If I can find the point here on its opposite direction, the angle's value, then I just choose the negative R. So we can find another 2 angles. So I need to find the angle of this point. So the angle of this point, for example, if I have 120 is from here to here. So I can plus the half revolution or plus 180. Let's use different color. From here to here plus 180. So it is my angle here. So 120 degree plus 180 degree. So the angle is negative 5, 300 degree. And how about the coterminal angle of this one? Okay, coterminal angle of what? So highlight this terminal side. Let's find the coterminal of this one. So based on this one, I can plus or minus 360. I have the coterminal. So they have the same R's value. Finding the same point, that means my angle plus or minus 360. So I can choose 300 degree minus 360 degree. So I'm going to have negative 60, negative 5, comma, negative 60 degree. So by this way, we found 4 points. If you feel it's confusing, let's practice more examples. Okay, let's see example 2. Plot a point given 3 equivalent expressions for the point. Okay, first, I need to find where is the point. So this 0, 90, 180, and 270 degree. And, the angle is 210 degree clockwise rotation. So I need to find my 210 is here. Okay, so this angle is 210 degree, and then the R is negative 4. I'm not plotting 1, 2, 3, 4. I'm not plotting this point. I'm going backward. So going backward, the terminal side is here. And the 1, 2, 3, 4. So this is my point. Okay, so I plot a point here. And then let me ask you, from this image, can you find the r comma theta in first quadrant? The theta is in the first quadrant. Yes, I can do that because what is the reference angle here for the 210? 30 degree. That means the opposite, the vertical angle is also 30 degree. So in first quadrant, I can tell the r is positive 4, and the angle is 30 degree. Okay, let's do 4 here. First, plot the point. And I see this point is in the first quadrant. In the first quadrant, and then I can tell that the r is positive 4, angle is 30, because that is the reference angle of my 210 degree. Okay, how about if I have the point in first quadrant, find the coterminal angle of this of 30 degree. So coterminal angle, they have same r, radius 4, and based on the 30 degree, I can do the clockwise rotation, minus 360. You can also plus 360. Second point is 4, negative 3, 30 degree. And then another point is given, which is negative 4, 210 degree. So we have learned the opposite terminal side helped us to graph my point. So graphing this one, first we find which angle is 210. So it's a line we highlighted now. And then we find the point which has the positive 4 radius. Now we need to find negative 4. So we do the backward. We go to the first quadrant. And now, if I'm still having the radius is negative 4, so my angle is same like this. Or finding the coterminal of 210 degree. Finding coterminal, I can base on the 210 minus 360 or plus 360. So my polar coordinates is negative 4, so do the math, is negative 150 degree. Okay, we found the 4 points. So another 3 points. So 1, 2, and 3. Okay, let's move on. Now, if we have the angle is not in the degree measure, it is in the radian measure, the same thing. So we say if it's in radians, we have 0, and we have pi, half pi, 3 power 2, and this is pi over 4, this is pi over 6, pi over 3. Now this one is pi over 12. Okay. Let's see, where is the angle? Negative pi over 3. So negative pi over 3, we are rotating clockwise. So it's here. Okay, so 5 means radius is 5. 1, 2, 3, 4, 5. Okay, I found my point in fourth quadrant. So first point is 5, negative pi over 3. If I want to find another 3 points, so we have 2 positive radius and the 2 negative radius. And then let's find the angles. For this one, the angle, if it's positive, that means I can do so based on this point, this this angle, I can rotate counterclockwise 360 degree. That is the coterminal angle. So let's find coterminal angle. We are using -pi/3 plus 2 pi. That is one full rotation. Is 5, 5 pi/3. So we do the math, add them together. Okay, next one. We need to find the terminal side. It's opposite with my my angle here. My point. So opposite is here. So use different color. And then so we need to find the angle from here to here or from here to here. So if I want to find the angle and with the r is -5, 1, 2, 3, 4, 5. Okay, it's the point here. So how to find the angle? Based on my terminal side here, we can plus or minus 180 degree. So for example, if I plus 180, not 180, plus pi, so we say negative, the given angle -pi/3 plus pi, rotate a half revolution, because I want to find plus pi is rotating this way. So I can find my terminal side, which is the opposite. Okay, so messy. And then this point is -5. The angle is 2 pi/3. So last one. So we need to find the coterminal of the point here. So the coterminal of this point is 2 pi/3. The backward rotation minus pi, because I'm 2 pi. Coterminal means plus or minus 2 pi. So based on this one, I'm going this way, come back to the terminal side. So this is the coterminal. This point is -5, comma, -4 pi/3. Okay, we use the 4 expressions to express the same point. Okay, we can erase the mass and then only keep one point here. Okay, we're done. Okay, let's see next example. Plot another point in the coordinate plane, in the polar coordinates plane. So let's find the point. R is -6. Theta is -5 pi/4. Let's start to find -5 pi/4. So this is 0. This is -pi. This is -half pi. And this is -pi. This is -3 pi/2. So if I'm looking for the -5 pi/4, so I'm rotating this direction. So put it here. And then, okay, so I'm rotating to here. So terminal side in second quadrant is here. And the R is -6. That means I'm not going this direction. 1, 2, 3, 4, 5, 6. I'm not plotting my point here. I'm plotting my point here. So that is the opposite. So we can use red color or use the highlighter. Highlight this one. I will say this is my actual points. Okay, so my first point, my R is -6, comma -5 pi over 4. I need another 3 points. So another 3 points. First two, they have the positive R, which is +6. And next one is -6. Let's find the angle. So if this one is given, can you find the coterminal of the angle -5 pi over 4? Yes, we can plus 2 pi or minus 2 pi. So the third angle can be found by this. So use -5 pi over 4. We can plus 2 pi. You can also minus 2 pi plus 4 pi. That is coterminal. So this point is -6, comma, do the math. We have 3 pi over 4, which is the positive. And then let's keep finding the finding the angle. Okay, we have so many methods to find the angle here and here. So first, some of you say, can I use a coterminal angle? Yes, I can use that. Because for the -5 pi over 4, our angle. So this angle is +5 pi over 4, which is my reference angle. That means this angle is also pi over 4. So if I have a point here and we have the positive R, which is 6, then this angle, I'm rotating the clockwise rotation, I have -pi over 4. And its coterminal is -pi over 4 plus 2 pi. So we have 6, 7 pi over 4. So this is one method. How to use another method to find these 2 points, these two angles value. So another one is, so we have learned this angle is -5 pi over 4. How about the backward rotation? We're rotating backward. Pi angle pi. So I got to the point here. So that means based on the -5 pi over 4, we plus pi, which is pi over 4. So that's how we find -pi over 4. You can also use this method. And then based on the -pi over 4. Based on the -pi over 4, we can plus 2 pi. So we can find 7 pi over 4. Okay, we can move on. Let's see next part. Okay, this one gave 3 points that are equivalent to the polar point -9, 270 degree. I will let you try. And after you tried, you can continue the video. First, I want to find the point on the polar coordinates. So 270, that means I'm rotating this way. And the radius is -9. I'm not picking this point. I'm picking a point here. It's the opposite direction. So I can tell that the point here is the actual point we are looking for. So this point describing the highlighted point, it is the angle 90. I didn't do anything about the 270 because from the graph I can tell that's 90. And the radius is +9. So 9, 90. 9, 90 degree. And then if I'm using -9, another +9, and then we can find the coterminal angle, which is 90 degree minus 360. So this is 9, -270 degree. And how about negative angle. So -9, and the given point is -9 to 70 degree. And the last one is -9, comma 270. Find its coterminal, -360 degree. It is -9, comma -90 degree. Okay, we found another 3 points. So here give 3 points. Ask you to find 3 points that are equivalent to the polar points. Let's find where is the point 3, 20 degree. So 20 degrees here. So 3, 20 degree is the point here. Okay, we have 3, 20 degree. And another angle, another point is also 3. Another angle is -3, an angle, -3, something. So the second one, they have this point has the same r as the 3 as the given points. So I can find the coterminal of 20, which is 20 degree minus 360. You can also plus 360. It all depends on the question. If the question says, find the point which my theta is greater than -360 and less than 0, for example, so you must find the angle is a negative angle, less than 0 degree and greater than or equal to -360 degree. It all depends on the question. Okay, so this point is 3, -340 degree. Okay, let's see next point. Next point, we need to find the opposite of my coterminal. Of the terminal side. So this is 20. This is the opposite angle or vertical angle. We say this also 20 degree. You don't have to say that's 20. You can say this is 20, and then add 180. Got here. So this point I can use 20 plus 180 degree. You can also use the reference angle to find the angle. So we have -3, 200 degree. And what is the last point? It has a same r's value. So I need to find the coterminal of 200. I should highlight 200. Coterminal of 200. So I can use 200 degree minus 360, which is -160. So -3, -160 degree. Okay, we can move on. So we need to find 4 different coordinates points for the point B with the angle in radians. Now, none of the points coordinates is given. We only have 1 point on this polar coordinate plane. So can you describe this red point by the polar coordinates? Yes, we can do that. This is a terminal side. What is the angle? I can find the r is 1, 2, 3, 4. Yes, r is 4. What is the angle theta? Okay, so this polar coordinate is starting from 0 degree, 90 degree, 180 degree, 270 degree, and then this is 30, this is 60. So one part here is 30 degree. Okay, that means this point is 180. So it's 180 plus 30, which is 210. So this point is 210 degree. All right, if I have another point, we have the same r. I need to find the terminal of 210, which is 210 degree minus 360 degree, which is negative 150, but I need to have my 4 comma negative 150 degree. And the next 2 points, they are negative 4 comma angle negative 4. Okay, I need to find the opposite of the terminal side. Here is okay. We need to find the angle of its opposite side. So the angle here I can tell is 30 degree. So I don't have to use this angle and then minus 180. Find that is 30, because from the graph I can tell it's 30. So faster way to find the 30 degree. And how about the coterminal of 30 degree? So it's 30 degree plus 180. Oh, why I'm adding 180? I'm adding 360 because coterminal means plus 2 pi or minus 2 pi. So I'm adding 360 degree or subtracting by 360 degree. So we have the angle negative 4 comma negative 330 degree. Okay, this part we are maybe we will make a small mistakes. Be very careful. Here is a hint. First two, they have the same R and the angle. They are the coterminal. You can use the first one minus 360, find the coterminal angle. You can also use this angle plus 360. You can find the coterminal angle. And then the next 2 points, they have the same R's value, which is negative. So based on the angle here, so we can plus or minus 180. So we got this one. And got this point, I can plus or minus 360. We can find the coterminal angle. Okay, let's move on to see next part. Convert polar coordinates to rectangular and rectangular to polar. So if I have a point, for example, I have a point on the terminal side here. So this point, if in the rectangular form, is x comma y. And for the polar coordinate, I need to find the r from the origin to the point. Here, the radius is r, and the angle is theta. We have r comma theta. And what is the relationship between r theta and the x comma y? So we can construct them. So we can construct a right triangle here. And in this right triangle, make it small, this is r. Oh, sorry, this is theta, this is r. And the opposite of the theta is y. And the adjacent of theta is x. Yes, because the distance from here to here is x. So if we have the cosine theta, that equals adjacent x over r. So I can isolate the r. Let's isolate the r. I'm saying x. Let's isolate the x multiplied by r both sides. Then we are going to have x is equal to r times cosine theta. And let's see what is the sine theta in this right triangle. Opposite y over hypotenuse r. So isolate the y. I can multiply by r both sides. Okay, we have y is isolated equals r times sine theta. That means if the given information is r comma theta, they are all given, my x comma x and y's value can be found by r is equal to cosine theta, y is equal to r times sine theta. So my xy coordinate is r times cosine theta, comma r times sine theta. So memorize that again. R theta is not equal to x comma y. They are different system to describe a point. Okay, now if the xy is given, how to find the r and theta? So come back to the graph here. So let's figure out the relationship. What is the r? R in this right triangle, it is the hypotenuse. So hypotenuse, the r squared is equal to x squared plus y squared. So r is equal to square root of x squared plus y squared. Yes, we found our r. How about the theta? So we can find it from the tangent, because the tangent of theta in the first coordinate is y over x, opposite over adjacent. Finding the theta, I can use the inverse. So the inverse of y over x is the angle we are looking for. So we can find the theta. From here, we can find the theta. But for example, the theta is not in first quadrant, it's in second, third, and fourth. We need to be very careful about the inverse function. We'll talk about that later. So convert the point form from rectangular coordinates into polar coordinates, where r is positive. Theta is between 0 to 2 pi. So that's one full revolution. Okay, what should I do first? I need to plot the point. By the given information, x, comma, y, I can find my point. So x is negative 2, y is negative 2 square root of 3. So the point is here. Okay, we want to find the r comma theta. So r is easy. R is has the formula is equal to square root of x squared plus y squared. And we plug in the x and y's value, negative 2 squared plus negative 2 square root of 3 squared. It is 4 plus 12, which is square root of 16, which is 4. Yes, we found our r. How about this theta angle from here to here? We need to find the inverse of tangent y over x, negative 2 square root of 3 over 2, and do negative 2. Do the cancellation, we have inverse of tangent positive square root of 3. Okay, so we can use our calculator. We can also just say is equal to theta. So tangent theta is equal to square root of 3. So theta must be 60 degree. 60 degree is pi over 3. But this one is the reference angle, because tangent in third quadrant is positive. Finding the inverse of positive tangent, so it's in first quadrant. If finding the inverse is negative, is in the fourth quadrant. I'm rotating this way. We learned this from trigonometry. So this theta is not the actual angle, that's the reference angle. So the actual angle we can use, so theta, maybe we say alpha, because now we have alpha is equal to pi plus pi over 3, which is 4 pi over 3. So the polar coordinates is 4, 4 pi over 3. It's asking us find it in the radian measure. Okay, let's see next one. Plot the point first. This video is super long. Okay, -3, 2, -3, +2. Okay, in second quadrant. Okay, so finding the r is easy. Square root of -3 squared plus 2 squared is 9 plus 4 is square root of 13. And finding the theta r. And here, I cannot say this is theta or alpha. So let's say alpha. And finding the inverse of tangent y over x, which is inverse of tangent 2 over -3. So we should use our calculator to do the computation. Okay. Oh, here. The calculator is here. So this is a radian measure. We want to make sure my calculator is in radian measure. Let's highlight radian. And then we have inverse of tangent, negative what? 2 divided by 3. Close the parentheses, hit enter. So it's about negative 0.59. So this angle is about negative 0.59. But this angle in second quadrant, it seems like a positive. How it can be negative? Because in second quadrant, tangent is negative. So when we find the angle for the tangent in second quadrant, we have negative value. Tangent of that angle is negative. So finding the inverse of tangent, positive in first quadrant, negative in fourth quadrant, and rotated clockwisely. So this angle is negative 0.59. And this is, so finding the angle is opposite of it. I can add 180 or add the pi unit. Okay, based on this angle, we can, so we say alpha is equal to negative 0.59 plus pi, because we want to rotate counterclockwise half revolution to find the angle in second quadrant. So the alpha is, so pi is equal to 3.1415 something. So add them together, we're having positive 2.55. So the point in the polar coordinate system is square root of 13, 2.55, which is the angle in radian measure. And later maybe we have the angle in the degree measure, and this one is in the degree measure. Okay, let's read the question here. So convert a point into the polar coordinate r, theta. R is positive, theta is in 1 revolution, and in the degree measure. Okay, let's see this example. First, plot the point. The point is 3, -5. Okay, it's here. We want to find the angle, let's say alpha or theta or any letter. Okay, finding the r is easy. So r is equal to square root of x squared plus y squared is equal to square root of 3 squared plus -5 squared. So we do the computation. It is 9 plus 25 is 34, square root of 34. And the next step is finding the inverse of tangent y over x, which is tangent negative 5 over 3. And we don't know how to find it by hand. We should use our calculator. So it's in the degree measure, I think. This time we need to change our calculator in the degree. And then we click second, tangent, and negative 5 divided by 3, close the parentheses, is negative 59 if I just round it to integers. So it's negative 59. This angle is equal to negative 59. But we know that my calculator can only give me the angle in this quadrant. If I'm looking for the angle, positive angle between 0 and 360, so that's a terminal angle. So we should add 360 degree. So come all the way back. So negative 59 is degree measure. Okay, so we're going to find the alpha. So alpha is equal to negative 59 plus 360 degree. So it's about 301 degree. So r comma theta is square root of 34 comma 301 degree. Okay, let's see last 3 examples. Convert the point from polar coordinates to the rectangular coordinates. The rectangular one is our old friend, is x comma y. So what is the formula between the x comma y and r comma theta? Is they are not equal, but we know that x is equal to r times cosine theta, and y is equal to r times sine theta. Okay, so in the expression, my r, this is r comma theta, r and theta, they are given. So finding the x is equal to r times cosine theta. So x is equal to 5 times cosine 300. What is cosine 300? So 300 is in fourth quadrant. Is here, reference angle is 60 degree. Finding the cosine 60. So cosine in ASTC. In fourth quadrant, cosine is positive, is equal to cosine 60, which is 1/2. So x is equal to 5 times 1/2, which is 2.5. You can keep the 1.5 over 2. You can also say 2.5. And y is equal to r times sine 300 degree. So r is 5. We can replace this one. Less steps. And then what is sine 300 degree? They have the same reference angle is 60. In fourth quadrant, sine is negative. We have negative sine 60 degree. So which is negative square root of 3 over 2. So 3 times negative square root of 3 over 2. Why I put a 3? So r is 5, it's not 3. Sorry, I confuse you. So r is 5, it's not 3. So do the computation. We have negative, top multiplied by the top, 5 root 3 over 2. So our x comma y is 5 over 2 comma negative 5 square root of 3 over 2. Okay, we can erase here and then move on to find the next one. Okay, you can read the example. This is r comma theta. So x is equal to negative 4 times cosine 5 pi over 6. And plug in the value of 5 pi over 6. So where is the 5 pi over 6? 5 pi over 6 is here. Not very pretty. Okay, this is 5 pi over 6, and reference angle is pi over 6. And cosine in second quadrant is negative. We have negative 4 times negative cosine pi over 6. Cosine pi over 6 is square root of 3 over 2. So x is equal to negative 4 multiplied by negative square root of 3 over 2, which is positive 2 square root of 3. So how about finding the y? Y is equal to negative 4 times sine 5 pi over 6. So y is equal to negative 4 times sine in second quadrant positive, and the reference angle is pi over 6. So it's multiplying by positive 1/2. Y is equal to negative 2. So the x comma y is 2 square root of 3 comma negative 2. How about next one? Next one, same, very similar. X is equal to 8.1, which is my r's value, multiplied by cosine 5.2. Let me ask you, the 5.2 is the angle or the radians? It is radians because it doesn't have the symbol, the degree symbol. That means when I plug in this one into my calculator, I want to change my mode to be the radian mode. So hit enter. Okay, I'm looking for r times cosine theta, which is my x value. So x is 8.1 times cosine 5.2. So we plug these into my calculator. So 8.1 multiplied by cosine. So cosine of 5.2. And then hit enter is 3.7949 something. Let's keep 2 decimal places. So the x value is about 3.79, and y's value is equal to 8.1 times sine 5.2. 5.2 is also radian measure. So we're using 8.1 multiplied by, So 8.1 multiplied by sine 5.2, close the parentheses, is negative 7.15. So 7.16. So y is equal to negative 7.16. X comma y is 3.79 comma negative 7.16. So that's the last question of 3.3. Have a good one.